Hello friends! Today we're going to discuss the Magic MIDI music box I developed for my sound and interactive media class at Purchase College. But first, an interpretive dance. You will notice that the Magic MIDI music box consists of 4 photoelastic light sensors and a box. This is the user interface. These light sensors pick up voltages between 0 and 5. I soldered 4 of these sensors to wires, shown here. These wires are then hooked into a breadboard, creating a circuit for resistive sensors. This is a diagram of the circuit I used, taken from the MIDI-Tron manual. The resistor is the light sensor, which resists the flow of energy based on how many volts it is receiving. This is how the circuit board looks. It is powered through the MIDI-Tron. There is the positive lead from the light sensor, followed by the terminal from the MIDI-Tron, then the negative lead from the light sensor. Immediately following that is a resistor, which goes to ground, which is the bottom row of the breadboard. This is the MIDI-Tron. Right now we are only using 4 terminals, 4 for the light sensors that are in the box. On the other side of the MIDI-Tron are the positive and negative leads that power the breadboard. The blue and red wires coming out of the MIDI-Tron are MIDI cables that go to my audio interface that route the information back to my computer. The MIDI-Tron has a companion program that allows you to send and receive information into your computer and translates the MIDI information. It allows you to activate specific terminals and define the parameters that it should be looking for. It also allows you to route the incoming MIDI signal from the audio interface to another program or back to the audio interface to control external devices. The MIDI-Tron programmer routes the raw MIDI signal to a max patch. The 4 terminals transmit their 4 separate MIDI signals on channels 1 through 4. These 4 subpatches convert the raw MIDI signal being sent by the MIDI-Tron programmer to pitch and velocity signals that are then usable by a synthesizer. Notice the sliders going up and down as the numbers change. Max then routes the pitch and velocity information to Ableton, where there are 4 tracks, 1 for each light sensor, that have synthesizers playing the note data that they are receiving. Through Ableton Live, you can control other factors determining the quality of the sounds produced. Ableton then sends the processed sound back through the audio interface, which then routes the audio back to the speakers. The speakers then route the audio back into your ears, and your ears route the audio back into your brain.